Hello, ladies and gentlemen of the internet. So tonight I'm going to do a quick 101 on BGP signaled VPLS as requested by I think two separate people. My original VPLS video was more of a hack of using a single CSR to aggregate pseudo wires from different 7200s. This one's going to be a little bit different. This one I have one, two, three, four CSRs. That's PE1, PE2, PE3, PE4, all CSR 1K or 1000s. And then everything else is a VIOS router. This could be really anything in GNS3. I just happen to like running VIOS because I have a GNS3 server and they're running in QEMU, so I like that. Could be 7200s for the P routers and the CEs on the edge here. So I'll do a quick walkthrough. We'll look at the CEs first because there's a little bit of existing configuration there. We'll just look at 1 and 2 just to give an example. Assigned. So every CE device has a gigabit Ethernet adapter facing the VPLS cloud and a loopback, and they're all running EIGRP on the gigabit and the loopback. So I'll show that on CE1 also. Show IP in brief. We'll exclude unassigned. There's our gig, there's our loop. We'll do show IP EIGRP interfaces. There's gig, there's loop. Notice no neighbors. The gig 00 interfaces are /24. In the 172.16.0 subnet, you can do show IP ARP. You'll see that there's nothing there except for our local. The CEs 1, 2, 3, and 4 are all IP'd in the 4th octet 1, 2, 3, and 4. So CE2, you'll notice we can't ping him. Can't ping 3. Can't ping 4. Just to establish a baseline. We're not going to look at the P routers a whole lot tonight because there's not a whole lot happening there. So I'll just look at P1 as an example. Exclude, unassigned. So the P routers have one interface going to the, we'll call them local PE. So P1 connects to PE1 and PE3, and then has two links to P2. P2 connects to PE2, PE4, and they're running OSPF only. That's the only routing protocol they're running. So we'll do a show run section router OSPF. And I'm lazy, so I'm doing MPLS LDP autoconfig. That just basically means any interface participating in OSPF is also participating in LDP. So we can do show MPLS LDP neighbor. You'll see all of our neighbors here as you'd expect. We're neighboring with P2 and we're neighboring with PE1 and PE3 here on this provider router. Just to establish a baseline. And again, this is going to be more of like a 101 video. I'm not going to go super deep. It's more so just to show you how to configure BGP signaling for VPLS. So we'll bring our prompts up. So far, there's not a whole lot of magic happening whatsoever. It's a pretty base config. All we have running on our provider routers is OSPF with MPLS LDP autoconfig. Again, I'll show that here on that PE. So MPLS, all of our 10 addresses participating in OSPF, and MPLS LDP autoconfig. That's running on all of our PE devices. And there's also a little bit of base BGP config, nothing significant. So show run section router BGP. We just have our global neighbors established, update source, loopback 0. None of the VPLS stuff is in yet. This is just a really base and basic config. So I don't have to type everything for this, and hopefully the video won't be like 30 minutes long. So we can do show IP route OSPF. You'll see that all of our loopbacks here. The way the loopbacks are set up, all of them are obviously /32. P routers are 10.0.0.1, 10.0.0.2. The loopbacks on the CEs are the router ID, I guess you'd say twice incremented. I don't know. So that's poorly explained. So the loopbacks for the PEs will be 10.0.0, then the router ID. So like PE2 is 22, PE3 is 33, PE4 is 44, and the local PE1 that we're on right now is 11. And then this is just the interconnects between the PEs and P routers that you see there. Okay, so let me just get this going. And the interface gig 2, you might have guessed from our rib right here, gig 2 faces the provider. Again, nothing special here, just an IP address slapped on there. All the MPLS stuff is within the OSPF config that I've already shown. Gig 1 is actually facing is what's facing the CE devices. So these are our gig 1 links right here. All right, so let's get started. We'll do. Trying to think how I want to do this first. You can tell I've totally rehearsed this video. We'll start with the VFI config. I'm going to do it in Notepad because it's a little bit. No, I'm not. I'm not going to do it in Notepad. I'm going to iOS help this to death. All right, so L2 VPN VFI context. We're going to give it a name. I'm just going to call it BGP VPLS because why not? We'll set our VPN ID. We'll do 100 just for keeping it easy. All right, so we're going to do auto discovery using BGP. Signaling is BGP. Could be signaling LDP, but we're not doing that. So signaling BGP. We have to set our VE ID, and this is the VE ID has to be unique between all your PEs. So VEID for PE1, we'll keep it easy, be VEID1. And much like if you're doing a layer 3 VPN with MPLS, we have to do our route targets and our route distinguishers. So we'll do route distinguisher of 65,000, 1, 2, 3, 4. We'll do route target. And we'll set both the import and export as 65,000, 1, 2, 3, and 4. Again, you probably recognize your route distinguisher and route target from layer 3 VPNs, but it carries over when we're doing BGP signaling for our layer 2 VPN right now. All right, so to show run, type in, we'll do section, L2 VPN, make sure I didn't miss anything. Have our VPN ID, have our signaling set, have our VE ID, our route distinguisher, route targets are set. That looks good. So I'm going to toss that into Notepad. We're going to keep that bit of config so we can copy and paste. All right. The next thing we have to do, and I'm actually going to put all this in Notepad from here. We have to go to router BGP. My ASN is 65,000. We're going to do address, family, L2 VPN, VPLS, and this is where we're going to put our neighbors in. I don't have any route reflectors. Wow. Brain farts. I don't have any route reflectors set up, so we have to do a full mesh of iBGP peers here. So I'm going to do 10.0.0.11, which is my local. That's okay, because it'll just error out. We'll say activate, because I already have it in the global BGP config. And neighbor 10.0.0.11, send community extended. Next thing we're going to do is neighbor 10.0.0.11 suppress, and it'll autocomplete from there, but suppress signaling, and we're going to suppress LDP. Let's put an explanation part there to break it up. All right, so we're going to do this for PE2, PE3, PE4. And then I'll copy and paste all this in onto router 1. I'll go ahead and put the BGP config on all the PEs right now, just to have it done. So we can go ahead and get our neighbor ships up. Bum, 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 bum. All right. The next thing we have to do is set up a bridge domain and a service instance on the gig1 interface, the interface facing the CE. So I'll do that on PE1 here. We'll go into int gig1 service instance. I'm going to use 80. Type is Ethernet. Again, this is a super basic VPLS config. Well, I would say it's super basic. This is a basic config for BGP signal VPLS, which is kind of advanced. So we'll say encapsulation, set it to untagged. You could have VLANs off of this, but we're not doing that today. So encapsulation's untagged. I'll go ahead and no shut the interface. And then the next thing we're going to do is set up our bridge domain to tie all this together. So bridge domain, I'm going to go ahead and just keep it consistent with 100 since that was our VPN ID also. They don't have to match, but that's the way I'm doing it. We're going to say member interface, or sorry, member, and specify the interface, which is gigabit Ethernet 1, service instance, I think I did 80, right? 80. And then we're going to tie this bridge domain together, or tie this interface together with the VFI that we just set up. So member VFI, we called it BGP VPLS. We'll see our pseudo wire come up. Or maybe not. Maybe we don't see the pseudo wire come up. All right, so just a quick recap. Do show run int gig1. We set up a service instance of 80. Encapsulation is untagged. Then on the bridge domain, we tied that service instance 80 on gig 1 to our VFI BGP VPLS. So let's steal this bit of config and this bit of config. All right, and then we're going to go over and change this VE to 2, and we'll apply this config to router 2. And in doing so, just because it's kind of interesting, I'll leave these two guys up. Yeah, so these two should become neighbors now. We'll see the EIGRP stand up. If I get console back on this, I might have to reset them. I'm going to pause the video real quick while I fix this CE device. All right, so he's back up now. Just make sure we're ready to rock here. All right, so we should see EIGRP come up between these two devices relatively quick once I apply this on PE2. Again, L2 VPN VFI contacts, we're naming it BGP VPLS, given it a VPN ID of 100, setting auto discovery to BGP with signaling of BGP, the locally significant VE ID of 2, a route distinguisher of 6500.1234, our route import and export, both 65,000.1234. Config on gig 1, just setting, actually let me drop in a no shut on here. Bringing the interface up, specifying a service instance of 80 with type Ethernet, setting encapsulation untagged, we're not doing any VLANs to anything like that, and then tying this bit of config and this bit of config together in our bridge domain. And they're already BGP neighbors in the address family of L2 VPN. This happens to me all the time. It tries to do the bridge config domain underneath the interface. Hold on. Do that. Now bridge config. And you can see our EIGRP adjacencies came up the second we did that. I'm going to close this guy down. Let me just toss a little extra config on here. Exit. Exit. All right, so we'll go to PE3. I'm actually going to leave this CE up so you can see the adjacencies form in the background. And we'll go over to PE3. All right. Change the VEID to 3. All right, there's our other EIGRP adjacency. We'll go over and change VEID to 4. On to PE4. And it looks like, there we go. Adjacency is up. We'll do show IP EIGRP. Neighbors should have 3 neighbors all over gig 00. Looks like 4 is flapping for some reason. I'll have to investigate that. Interesting. Well, no matter. We'll do show IP route EIGRP. We'll ping the loopbacks of 2, 3, and 4. And just to show that there's no trickery happening in the MPLS cloud, this is direct because of our L2 VPN. I'll trace route to 172.16.255.4. You'll see the only hop is going through CE4. Okay. So before you cancel out this video or close out this video, we'll quickly go through. I'll review the config on one of the PEs just for your reference, and then I'll show you some verification commands also. So we'll look at the config again. First bit is setting up. Oh, let me throw a caret on there. Setting up our VFI, so it's L2 VPN. We gave it a context name of BGP VPLS, and all this here that you can see on the screen. Next important bit is setting up BGP. The address family L2 VPN VPLS. You can see a full mesh of our iBGP peers. Setting extended communities and suppressing LDP for signaling. The interface facing your CEs. We have a service instance. I gave it the number 80. You can pick any service instance identifier 1 to 8000 and set the encapsulation untagged. And then tie your L2 VFI and your service instance together in a bridge domain. And I did bridge domain 100. And that's it. Some verification commands we can do. We can do show L2 VPN, VFI, and then you can see our pseudo wires that are stood up and the peers that we're with. One that I like a lot, you can do show bridge domain mines 100. You can see where our MACs are mapping to. So we have our locally learned MAC of CE1 on gig 1, and then you can see these remote MACs and what peers they tie up to, or rather what pseudo wires they're tied to. And those are the two big ones. You can also see under our bridge domain our BGP peer set up here also. So again, that's show L2 VPN VFI, show bridge domain, where you get a lot of good output. And one last one that I used for some debugging purposes when I was trying to get this working, show xconnect all. When I was doing my initial setup and I couldn't get things to work, I would see these messages. I would show that the xconnect or XC is up, but that the configuration was incomplete, and that's how I started trying to work my way through this config. So again, this is more of like a 101, just so you can see what the configuration looks like and hopefully build this out in your own lab. Based on feedback from this video, if you guys want more deep dives and packet captures and a better explanation of what's happening behind the scenes, I'd be happy to provide that. Just let me know in the comments.